Hello, calculus students. We're here in section 7.7, finding particular solutions using initial conditions and separation of variables. So we have in this problem, we have y times secant squared x is my dy dx. And we are definitely going to be solving this by separation of variables. When you have a function of x times a function of y, we're going to separate. So we're going to have, on the left-hand side, we'll say dy over y. In the right-hand side, we're going to get secant squared x dx. Now we're going to integrate both sides. Now we have to be careful that we don't always think this is going to be a natural log, but if it's just y or y minus 1 or some linear function of y, it will be a natural log. So just be careful in later problems if it's not just a linear function down here on the bottom. Okay, so we have the natural log of the absolute value of y is going to equal, and then the antiderivative of secant squared is tangent x. And then we have our little plus c. So now we're going to use the initial condition and solve for c. Sometimes you can solve for c at the end, or you can solve for c at this stage of the problem. So we're going to have y is 5, so I get the natural log of 5 is equal to, and then tangent of 0 plus c. Well, tangent of 0 is sine of 0 over cosine 0, and since sine of 0 is 0, we're going to get 0. So we can easily see that the value of c here is the natural log of 5. So c is equal to the natural log of 5. And then we're going to take this, and we're going to take this c out and put our natural log of 5 in, and then we're going to solve for the function y. Okay, so we're going to have y is equal to, and we're going to solve that by exponentiating this. So we're going to say e to the, well, it's going to be e to the tan x plus ln 5. And obviously, that would be a correct way of giving an answer, but we can probably clean this up a little bit. We get e to the ln 5 times e to the tan x. And we can go one step further. We can say that e to the ln 5 is just 5. And then we have e to the tan x. And that would be my final answer. 5 times e to the tan x.